In 2012, the Nokia 808 PureView quietly shipped to British high street shops. It featured a remarkable camera, but to the mobile industry, it was a funeral. It was the final smartphone to run Symbian. Just 5 years earlier, this British-born operating system controlled over 60% of the global smartphone market. It powered hundreds of millions of devices, dictating the shape of mobile computing and dominating the shelves of every Carphone warehouse in the country. Then the ecosystem collapsed. Developers abandoned the code. Retailers cleared their window displays. A system designed to rule the mobile age was erased almost overnight by capacitive glass screens from California. The paradox is that Symbian did not fail because it lacked technical capability. It failed because it was perfectly engineered for a market that suddenly ceased to exist. But the real story of Symbian is not only the story of a dying phone in 2012, it is the story of how a British pocket computer architecture built the global smartphone industry, only to be crushed by the very future it invented. Every week, we tell the stories of British machines, platforms, pocket computers, and software houses that once taught the country what the future felt like and what happened when the global market moved on. Subscribe if that history matters to you. The story of Symbian begins not with nostalgia, but with a specific alliance in a London office in 1998. Before a mobile phone could become a computer, Britain already carried computers in its pockets. To understand why the world's largest mobile phone manufacturers quietly gathered in London in 1998, you first have to look at what was missing from the British high street. In the mid-1990s, a professional commuter traveling from Reading into London Paddington usually carried a briefcase containing two completely separate digital worlds. The first was a mobile phone, a heavy plastic brick with a small monochrome screen, used strictly for voice calls and perhaps the occasional short text message. It was a communication tool, not a computing device. The second device was a PDA, a personal digital assistant, a handheld device used for contacts, calendars, notes, and simple computing before smartphones took over. And in Britain, the PDA market was ruled almost entirely by one domestic company, Symbian. Since the 1980s, Symbian had been building pocket organizers that were essentially miniature computers. By 1997, they had released the Symbian Series 5, a device that became a status symbol in British offices and university staff rooms. It featured a sliding clamshell design, a remarkably tactile keyboard, and most importantly, an entirely new operating system called EPUX 32. An operating system, the core software that manages the computer and lets other programs run, dictates exactly what a machine can and cannot do. The genius of EPUX 32 was its extreme efficiency. A desktop computer plugged into a wall could afford to be wasteful. A pocket computer running on two AA batteries could not. EPUX 32 was designed from the ground up to handle memory, the fast temporary storage a computer uses while programs are running, with absolute precision. If a user was typing a document on a train and simply snapped the lid shut, the system instantly suspended itself. When opened days later, the cursor would be blinking in the exact same spot. It was a masterclass in British software engineering. But Symbian knew that a collision was coming. The problem was not the machine. The problem was the ecosystem around it. The mobile phone was shrinking rapidly. Soon, phone manufacturers would want to put calendars, address books, and email capabilities directly into their handsets. If a mobile phone could do everything a PDA could do, the standalone pocket computer would become obsolete. Symbian needed to get its software inside the mobile phone before the mobile phone swallowed the PDA market entirely. At the exact same time, a much larger threat was looming across the Atlantic. Microsoft, having achieved near total dominance over the desktop PC market, was preparing to move into mobile devices with a stripped-down operating system called Windows CE. This terrified the global mobile phone giants. Companies like Nokia, Ericsson, and Motorola had watched what Microsoft had done to the personal computer industry. They had seen how hardware makers like Compaq, Dell, and Gateway had been reduced to low-margin assemblers of beige boxes, while Microsoft held all the power and took all the profit by controlling the software standard. The mobile giants knew that if Microsoft's operating system became the standard for the next generation of phones, they would lose control of their own industry. They needed an alternative. They needed an operating system that was incredibly power efficient, designed specifically for mobile hardware, and crucially, independent of Microsoft. Symbian had exactly what they needed. In June 1998, a historic alliance was formed. Symbian spun off its Epoch software division into a completely new, independent software company based in Southwark, London. It was called Symbian Limited. The ownership was a joint venture. Symbian held the largest initial share, while Nokia, Ericsson, and Motorola became co-owners. This was a profound structural shift in the global technology market. Fierce rivals, companies that fought bitterly for shelf space in every Dixon's and independent mobile shop across the British High Street, had agreed to share the exact same underlying software core. The task facing the engineers in London was immense. Building an operating system for a pocket organizer was difficult, but building one for a mobile phone was entirely different. A phone is not just a computer, it is a real-time radio device. If a PDA crashes while loading a calendar, it is an annoyance. If a mobile phone operating system stutters while processing a background task and misses an incoming network signal, a phone call drops. The core software had to be perfectly stable, dividing its attention between the cellular radio and the user interface without ever dropping a vital communication packet. Symbian was not designed to be a single product sold in a plastic box on a retail shelf. It was built to be a platform, a technology system that other products, developers, users, or services build around. The London-based company would provide the core architecture, the deep engine room of the software. The hardware manufacturers, Nokia, Ericsson, and others, would license this core and build their own user interfaces on top of it. This meant that two completely different phones from two competing brands could look different, feel different, and be sold to different types of consumers, yet run on the exact same British code base. In its early days, the company operated with a quiet, intense focus. The software engineers in Southwark were expanding EPO 32, rewriting its connectivity layers, and preparing it for a world where devices would always be connected to the internet. They were designing a system that could handle the strict power constraints of mobile processors, the main chips that perform calculations and execute instructions, while providing enough flexibility for future third-party software developers. Available records suggest the atmosphere was one of immense ambition mixed with high-stakes pressure. Symbian had the backing of the biggest hardware manufacturers on the planet. It had the technical pedigree of Symbian. It had the defensive motivation to keep Microsoft out of the mobile space. But a platform does not exist until it is in the hands of users. The high street shelves were still filled with basic monochrome phones that did little more than make calls and send texts. The promise of the smart connected device was still theoretical. The engineers had built a brilliant engine, but it was currently sitting in a laboratory invisible to the public. The alliance was formed, the code was British, and the target was clear. Now the new company had to prove it could fit a computer inside a telephone. The first device to prove that the London-based alliance could actually merge a pocket computer with a telephone arrived in late 2000. It was the Ericsson R380, and it was a revelation. To the casual observer, it looked like a standard, slightly bulky mobile phone, but the physical keypad could flip open to reveal a large, monochrome touchscreen, a display that also responds to finger or stylus input. This was the first device to ever be officially marketed using the term smartphone, a mobile phone that combines calling, internet access, and computing power. It ran on a very early version of Symbian, but the R380 was only a bridge. It was a closed system, meaning users could not easily install their own third-party software. The true breakthrough, the device that changed the British high street and proved the raw power of the British codebase, arrived 2 years later. Released in 2002, the Nokia 76050 did not look like a traditional pocket organizer. It was a sleek slider phone with a bright color screen and, most shockingly for the era, a built-in digital camera. But beneath the plastic shell, it was a fully functional computer, running a Symbian core paired with Nokia's new user interface, known as S60. To understand why the 7650 was such a technical triumph for the British engineers, You have to look at memory. Memory, fast temporary storage a computer uses while programs are running, is plentiful on a desktop PC. But on a mobile phone in 2002, it was incredibly scarce. The Nokia 7650 had just 4 megabytes of storage space and even less working memory. If a desktop computer ran out of memory, it simply slowed down or froze until the user restarted it. But if a phone froze while a user was taking a photograph just as an incoming network signal arrived, the phone call would drop and the device would fail at its primary purpose. Symbian's deep Scion heritage prevented this. In a bustling pub in Camden, a user could slide open the 7650, take a VGA resolution photograph, open a text message to send it, and receive a voice call simultaneously. The British-designed operating system ruthlessly managed the power and memory, pausing background tasks with microscopic precision so the hardware never stuttered. It did not require a massive battery or a hot desktop-grade processor to achieve this. It achieved it through elegant, highly disciplined code. This efficiency completely changed how technology was sold in Britain. Walk into a Carphone warehouse, a Phones 4U branch, or a Dixon's in 2003, and the Nokia 7650, alongside its successors like the Nokia 3650 and the Sony Ericsson P800, were placed at the very front of the display windows. These machines were expensive, often costing over £300 without a contract, but they were heavily subsidized by British telecom networks like Vodafone, O2, and Orange. The networks desperately wanted customers using data to send picture messages and browse the early mobile internet. Symbian devices were the only machines capable of doing it reliably without draining the battery in 3 hours. In the pages of Mobile Choice and other British computer magazines, reviewers marveled at the capabilities. The software was no longer just a hidden utility to make the phone ring. It was the primary selling point. Because Symbian was an open platform, a technology system that other developers could build around, a massive new industry began to form. Professional software houses and bedroom coders realized they could write complex programs for these devices, bypassing traditional retail entirely. Before the concept of an app store existed, Symbian users were building an organic ecosystem. A pupil in a comprehensive school could use a dial-up modem at home to download a game from an online forum, transfer it to their phone via an infrared beam or early Bluetooth, and install an entirely new application. A commuter traveling to Manchester could install a third-party MP3 player, an advanced calculator, or a rudimentary sat-nav system directly onto their handset. They were doing exactly what Scion users had done in the 1990s, but now the device was permanently connected to a cellular network and slipped neatly into a jacket pocket. Meanwhile, Microsoft's Windows CE, the system that had terrified the mobile giants into forming Symbian in the first place, was struggling to catch up. Microsoft's software required significantly more processing power, drained batteries faster, and felt like a desktop operating system awkwardly crammed onto a small, restricted screen. Symbian, born directly from battery-powered pocket computers, felt natural, responsive, and invisible. The alliance had worked perfectly. By providing a stable, brilliantly efficient core, Symbian allowed hardware manufacturers to experiment wildly with different phone designs. Nokia built sliders, Motorola built flip phones, and Sony Ericsson adopted a different Symbian variation called UIQ, which relied heavily on a stylus, a small plastic pen used to tap the screen. They all looked entirely different on the shelf, aimed at completely different customers, but deep inside, they all spoke the exact same British language. The technology was proven. The telecom networks were paying for the distribution. The high street had fully embraced the smartphone. Symbian had successfully solved the hardware problem. It was about to discover what happened when a phone OS became the most powerful platform on Earth. By 2005, you could walk down any high street in Britain, from Oxford Street in London to a local shopping precinct in Leeds, and see the total physical dominance of the London-born platform. If you stood outside a Carphone warehouse, a Phones 4U, or an independent mobile shop, the window displays were a chaotic, vibrant gallery of hardware. There were flip phones, sliding phones, phones that twisted at strange angles, and heavy communicators with full physical keyboards that opened like miniature laptops. A customer could buy a Nokia N70 to take photographs, a Sony Ericsson P990 to manage spreadsheets with a plastic stylus, or a Motorola device to check emails on a train. To the average British consumer, these machines appeared to be fierce, entirely separate rivals fighting for supremacy on the shelves. But beneath the plastic, glass, and metal, they were all speaking the same language. They were all running on Symbian. In a British high street where mobile phones were sold like fast fashion, the right operating system did not merely process calls. It decided who first carried the internet in their pocket, who stopped buying standalone digital cameras, who built the first mobile software businesses, and who controlled the bridge between the personal computer and the mobile future. The scale of this invisible British empire was staggering. By the mid-2000s, Symbian OS was powering over 60% of the global smartphone market. The company, still headquartered in Southwark, London, had grown from a defensive alliance against Microsoft into an absolute juggernaut. It was shipping in tens of millions of devices every single quarter. British network operators like Vodafone, O2, and Orange built their entire high-margin data plans around the capabilities of these machines. A vibrant, uniquely British digital culture began to form around the platform. On newsagent shelves in W.H. Smith and John Menzies, computer magazines that had once been dedicated entirely to desktop PCs began sharing space with publications like What Mobile and Smartphone and Symbian. Readers would scour the pages for reviews of the latest Nokia hardware, but increasingly, they were also looking for software. A massive community of enthusiasts and bedroom coders gathered on websites like All About Symbian, a UK-based hub that became the global center for news, reviews, and developer discussions. Here, users took advantage of a practice known as sideloading, installing software directly onto a device from a computer via a USB cable or a Bluetooth connection, completely bypassing any central authority or official retail shop. If a pupil in a Manchester comprehensive school wanted a new game, they did not buy it in a plastic box. They downloaded a .sys installation file from an online forum, transferred it to their Nokia, and played it under the desk. If a surveyor in Birmingham needed a specialized tool to calculate measurements on-site, a small British software house could write the code, package it, and sell it directly to them over the internet. This was the birth of the mobile app economy, happening years before the concept of a centralized app store existed. And it was all built on the ruthless efficiency of the Cyan-derived Epoch architecture. Microsoft's Windows Mobile was still struggling to shake off its heavy, desktop-like interface. American companies were largely focused on either simple feature phones or business pagers like the early BlackBerry. Britain had effectively provided the blueprint for the consumer smartphone, but this incredible scale masked a deep structural flaw. Symbian was a platform, but it was not a unified experience. Because the operating system was designed to let hardware manufacturers build their own interfaces on top, the ecosystem became violently fragmented. Nokia championed the S60 interface, which relied on directional buttons and soft keys. Sony Ericsson and Motorola heavily backed UIQ, an interface built primarily around touchscreen input and a stylus. While they shared the same core engine, the interfaces were so radically different that software written for a Nokia S60 phone would not easily run on a Sony Ericsson UIQ phone. A developer sitting in a startup office could not just write a program for Symbian. They had to write it for S60, test it, and then completely rebuild the user interface for UIQ if they wanted to reach the entire market. Network effects, the pattern where a platform becomes more valuable as more people use it, were working in Symbian's favor when it came to selling hardware, but they were beginning to break down for the people actually writing the software. The hardware giants had used the British codebase to conquer the world, but they refused to unify. They were fighting each other using the exact same software engine, creating an ecosystem that was massive on the outside, but deeply fractured on the inside. The platform was generating unprecedented wealth, but the fault lines that would eventually tear it apart were already mapped out in the code. In early 2007, the ultimate expression of this fragmented British empire arrived on the high street, the Nokia N95. It was a dual sliding monolith that felt less like a telephone and more like a dense piece of military hardware. To a customer walking into a mobile shop in Bristol, it was a revelation. It featured a 5-megapixel camera, built-in GPS navigation, and high-speed 3G internet. It was powered entirely by Symbian, using Nokia's S60 interface. The N95 proved that the British operating system could handle massive streams of multimedia data. A user could slide the screen down to reveal media keys, play an MP3, slide it up to reveal a keypad, open a web browser, and receive a voice call all simultaneously. The OS managed the memory so efficiently that the device did not overheat in the user's hand. At this moment, Symbian's market share was unassailable. It controlled nearly 70% of the global smartphone market. In British universities, computer science students were buying thick textbooks on Symbian C++ programming, believing it was the definitive language of the mobile future. The company's headquarters in London was the center of the mobile universe. Symbian was not just a successful company, it was a British technology standard that had successfully fended off Microsoft and dictated the terms of global mobile computing. But beneath this monumental peak, the ecosystem was beginning to suffocate its own creators. To understand why, you have to look at APIs, application programming interfaces, a controlled way for software systems to communicate. If a developer sitting in a small startup office in Shoreditch wanted their new application to use a phone's camera, they had to write code that spoke to Symbian's camera API. But because Nokia, Motorola, and Sony Ericsson had built radically different interfaces on top of the Symbian core, the tools developers needed were entirely fragmented. Writing an application was an exhausting process of testing, breaking, and rewriting code for dozens of slightly different phone models. Furthermore, as smartphones became powerful enough to access the internet directly, British network operators like Vodafone and O2 grew terrified of malware. Malicious software that could secretly send premium-rate text messages and drain a customer's credit. To appease the networks, Symbian introduced a system called Symbian Signed. Symbian Signed was a mandatory security certificate system. To get a program onto a user's phone, a developer could no longer just upload an installation file to a British enthusiast forum for anyone to download. They had to submit their code to a central authority, wait weeks for testing, and pay a significant financial fee for a digital certificate. For a large multinational software house, this was a manageable expense. For a bedroom coder in Leeds trying to share a simple custom calendar app, or a small British studio trying to release a game independently, it was an insurmountable brick wall. The organic, user-driven ecosystem that had made Symbian so vibrant in the early 2000s was suddenly locked behind corporate bureaucracy. The British codebase had successfully put a computer in every pocket. It had taught the high street how to sell the mobile internet. It had built the foundation of the modern smartphone industry. Symbian owned the pocket, the high street, and the global market. But that same massive scale, fractured by competing hardware brands and locked behind expensive developer certificates, would soon become its deadliest trap. The first crack in the British mobile empire was not a spectacular hardware failure on the high street. It was a quiet, bureaucratic frustration inside the offices of British software houses and the bedrooms of independent coders. Before 2007, Symbian's sheer scale had hidden the friction in its ecosystem. But the introduction of the Symbian Signed Certificate system changed the atmosphere. Independent developers, the very people who had built Britain's vibrant software culture since the days of the cassette tape, found themselves locked out. If a programmer in Manchester built a brilliant new messaging application, they could no longer simply share it on a forum. They had to pay hundreds of pounds, submit their code to a central testing authority, and wait weeks for approval just to get their software onto a Nokia device. This exposed the system to what industry analysts identify as Force 3, standards, ecosystems, and developer support. A platform can be technically flawless, but if the developer ecosystem stops growing, the trap snaps shut. A machine needs users to attract software, and it needs software to keep users. Symbian had the users, but it was actively punishing the developers. Then the market experienced a seismic shift. In January 2007, Apple announced the iPhone. When it arrived in the UK later that year, initially as an exclusive through the O2 network, it did not immediately destroy Symbian's sales. The first iPhone was expensive, lacked 3G connectivity, and could not record video, features that Nokia's Symbian devices had mastered years earlier. But the iPhone introduced a capacitive touchscreen, a display made of glass that responded to the electrical properties of the human finger, rather than requiring the firm pressure of a plastic stylus. Suddenly, the Symbian interface felt fundamentally old. Nokia's S60 was built for physical directional pads and soft keys. Sony Ericsson's UIQ was built for resistive touchscreens that required deliberate, heavy taps. The underlying British EPOC architecture was a marvel of memory management and battery efficiency, but it had never been designed for fluid, finger-driven scrolling. The code was deeply tied to a physical paradigm that had vanished overnight. This was the brutal reality of Force 4, global scale, American standards, and convenience displacement. The global market was moving towards a singular, seamless software ecosystem. The fatal blow did not come from the iPhone's hardware. It came from its software distribution. In 2008, Apple launched the App Store, a controlled marketplace where users could find and install applications with a single tap. Apple bypassed the high street retail shops completely. They bypassed the telecom network portals. Most importantly, they bypassed the fragmented developer nightmare that Symbian had become. For a developer in a London startup, the choice was suddenly stark. They could spend months writing code in Symbian C++, testing it across 20 different Nokia models, rewriting the interface for 3 Sony Ericsson models, and paying for a Symbian signed certificate. Or they could write one piece of code for iOS, upload it to Apple, and instantly reach millions of identical glass screens, with Apple taking a 30% cut of the revenue. The convenience displacement was absolute. In a desperate bid to save the platform, the corporate structure of Symbian was radically altered. In 2008, Nokia bought out the remaining shares from Ericsson, Sony Ericsson, and Motorola, effectively ending the joint venture that had been forged in Southwark a decade earlier. Nokia established the Symbian Foundation, headquartered in London, and announced that the entire Symbian operating system would be made open source, free for anyone to use and modify. It was an ambitious attempt to counter the rise of iOS and a new, looming American threat, Google's Android, which offered manufacturers a free, modern, touch-first operating system without the legacy baggage of the 1990s. But the Symbian codebase was simply too vast and too fragmented. Over 10 years of modifications, patches, and manufacturer-specific tweaks had turned the elegant Cyan-derived engine into a tangled labyrinth. When developers looked at the newly opened code, they did not see a flexible future. They saw an aging monolith. The network operators sensed the shift. In Carphone warehouse displays across the country, the diverse gallery of sliders and communicators began to shrink. The shelves were being cleared to make way for identical black glass rectangles. Symbian was still shipping in tens of millions of low to mid-range phones, maintaining a massive global market share on paper. But the cultural energy had evaporated. The machines still worked. The ecosystem around them had already collapsed. Script begin. The Long Decline. 29-20-35-15, Part 2. By 2010, the British High Street was a visual timeline of a platform in freefall. Inside any Carphone warehouse, the front display windows, once exclusively reserved for Nokia and Sony Ericsson devices running Symbian, were entirely dominated by the Apple iPhone and the rising tide of Google Android devices like the HTC Desire. Symbian phones were being pushed toward the back of the shop, relegated to the budget shelves or sold as pay-as-you-go devices for users who simply wanted a cheap camera. The Symbian Foundation, based in London, had tried to save the ecosystem by releasing the operating system as open-source software, but it was a catastrophic miscalculation. The code base was simply too old, too complex, and too fractured. Developers in British startups who had once bought thick manuals to learn Symbian C++ were completely abandoning the platform. They were migrating to iOS and Android, where they only had to write an application once to reach millions of users, without paying exorbitant certificate fees or rewriting user interfaces. This was Force 5 in motion. Corporate consolidation, foreign acquisition, brand survival, and cultural memory. The British technology was being suffocated not by a lack of engineering talent, but by American corporate ecosystems that had solved the distribution problem. The fatal blow was delivered in February 2011. Stephen Elop, the newly appointed chief executive of Nokia, released the now infamous burning platform internal memo. He directly compared Nokia's reliance on Symbian to a man standing on a burning oil platform in the North Sea, stating that they were pouring fuel onto the fire by clinging to an outdated operating system. Days later, Nokia announced it was abandoning Symbian entirely to partner with Microsoft and adopt Windows Phone. The irony was crushing. 13 years earlier, Symbian had been created in a London office specifically to prevent Microsoft from taking over the mobile phone industry. Now the largest founding partner was killing Symbian to invite Microsoft in. The collapse of the ecosystem was instantaneous. When a platform owner announces the end of a system, the network effects run in reverse. Knowing that no new Symbian phones would be developed after the transition, British telecom networks like Vodafone and O2 immediately began dropping their support. Computer magazines stopped reviewing Symbian software. Independent developers pulled their apps from the fragmented storefronts. There was no longer any financial incentive to maintain code for a dying platform. A machine needs users to attract software, and it needs software to keep users. Once Nokia publicly executed the platform, the loop was permanently shattered. The final act of the Symbian empire was not a spectacular battle, but a quiet, confusing hardware release. In 2012, Nokia released the 808 PureView. It was a technological marvel featuring a stunning 41-megapixel camera that no American or Asian competitor could match at the time. It was the ultimate expression of Symbian's hardware efficiency, but it was shipped with an operating system that the manufacturer had already admitted was dead. When it arrived in British shops, it was treated as a curiosity rather than a consumer product. The operating system felt heavy, the web browser was clunky compared to a modern smartphone, and the apps that British users now expected, like modern social networks and instant messengers, simply were not there. The hardware was brilliant. The ecosystem was empty. The transition was absolute. Within a few short years, an operating system that had commanded over 60% of the global smartphone market dropped effectively to zero. The London headquarters of Symbian was dissolved, its legacy codebase outsourced and quietly retired. The British pocket computer architecture that had successfully bridged the gap between the PDA and the mobile internet was erased from the daily habits of millions of users. The code was abandoned. The factories pivoted. The developers followed the larger market. The telecom networks moved on. The high street windows were cleared. The screens were replaced with Californian glass. The logo disappeared. The habit was gone. The death of the Symbian empire was not a sudden explosion on the high street, but a slow, managed bureaucratic dismantling. By the end of 2012, Nokia had effectively outsourced the remaining software support and maintenance of the Symbian codebase to Accenture, a global consulting firm. The engineers who had once written the defining language of the mobile revolution in Southwark were reassigned, their deep knowledge of mobile efficiency quietly absorbed into enterprise IT management. In January 2014, Nokia officially stopped accepting new applications or updates to the Symbian storefront. The Symbian signed certificate system, the very mechanism that had once suffocated independent British developers, was permanently shut down. The digital gates were locked. The operating system could no longer be officially updated, modified, or legally expanded. The platform was entirely dead as a commercial entity. Today, if you want to understand the scale of what was lost, you cannot look to the corporate entities that created it. The original joint venture that formed in a London office in 1998 has been completely dissolved, its hardware partners either absorbed by larger conglomerates, sold off, or radically diminished in the smartphone era. Instead, the survival of the British codebase is entirely in the hands of the digital preservation and vintage enthusiast community. Across the UK, a dedicated network of collectors, digital archivists, and vintage hardware repair technicians continues to keep the Symbian ecosystem artificially alive. They scour car boot sales, charity shop electronics bins, and eBay listings to rescue abandoned hardware. On the Internet Archive and on the long-standing British enthusiast forum All About Symbian, users still share vast, carefully curated repositories of old .sys installation files. Because the official certificate servers are permanently offline, Modern users must rely on custom firmware or specialized hacking tools simply to bypass the dead security protocols and install a basic game onto an old Nokia N95 or Sony Ericsson P800. In digital spaces, international programmers contribute to projects like EKA2L1, an open-source emulator designed to perfectly recreate the core Symbian architecture on modern desktop computers. They are meticulously reverse engineering the Epoch 32 memory management systems so that the software history of the early smartphone era is not permanently erased. This is not nostalgia. A chunky dual-sliding Nokia N95 or a stylus-driven Sony Ericsson resting on a collector's workbench is a physical argument about a time when computing was not yet a homogeneous, flat sheet of capacitive glass. It is a physical reminder of a Britain where the high street windows offered true hardware diversity and where software had to be ruthlessly disciplined to run on miniature batteries. These old machines prove that technical superiority and extreme code efficiency are never enough to guarantee survival. Symbian built the very concept of the mobile app ecosystem before the term App Store even existed. It proved that a platform can dominate the world, hold hundreds of millions of users, and still be utterly destroyed if it fails to make software distribution frictionless for its developers. The physical legacy of this era is now carefully curated behind museum glass. If you visit the Center for Computing History in Cambridge or the Science Museum Group's archives, you can trace the direct physical lineage of the British mobile empire. You can look at a Science Series 5 pocket organizer with its brilliantly tactile keyboard and see the exact same underlying software philosophy that would later power an entire generation of global mobile phones. The hardware changed shape, but the British logic remained the same. There is a profound footnote to the Symbian story. The brutal efficiency that the London engineers built into the Epoch architecture in the late 1990s, the philosophy of performing incredibly complex calculations while using almost zero electrical power, did not entirely vanish from the world. It became the foundational paradigm of the entire mobile industry. The American operating systems that eventually displaced Symbian, such as iOS and Android, were only able to succeed because they ran on ARM processors, another British technology standard that understood exactly how to manage mobile power. Symbian lost the software war, but the hardware rules it helped establish became the permanent global standard. Britain did not lack the vision to invent the future of mobile computing. It built the exact operating system that took the digital world out of the briefcase and put it firmly into the pocket. It taught the high street how to sell the mobile internet, and it taught a generation of users that a telephone could be a fully functional personal computer. But Britain lost the system that turned that invention into a permanent ecosystem. The platform fractured, the developers grew exhausted, and the market demanded a level of seamless convenience that the old architecture simply could not provide. The underlying code was brilliant, but the global market moved on. Somewhere in a British loft, a Nokia smartphone still rests inside a forgotten box, its thick plastic chassis and tactile buttons gathering dust, waiting for a battery charge that will momentarily wake an operating system that once quietly ruled the world. See you in the next video.